Section 4's properties of rational exponents are using the same properties that we already know. We already know that if we multiply like bases, we add the exponents. We already know that if we raise a power to a power, we multiply the exponents. We already know that if we have two bases multiplied together, raised to a power, that we can kind of like distribute the exponent in, and now we have that base to that power times that base to the same power. We already know that a to the negative m means 1 over a to the positive m. We already know that when we divide like bases, we subtract the exponents. And we already know that when we are dividing different bases, all raised to one exponent, we can like distribute that exponent in and wind up with a to the m divided by b to the m. We already know all those. So we're just showing that these properties that we already know also apply to rational exponents here with these examples. So for the first example, we have like bases, a to the 1/3 times a to the, what is that? 2/3. When I multiply like bases, I add the exponents. So 1/3 plus 2/3 is 3/3, which reduces down to 1. So you wind up with 8 to the first, or just 8. When we are raising powers to powers, we multiply the exponents. So this looks like 5 to the 1/2 to the 4th power. I multiply 1/2 times 4, and I get 2. So I wind up with 5 squared, which is 25. When I have different bases to a power, then I can send that power in. And I wind up with 4 to the 1/2 times 5 to the 1/2. Well, 4 to the 1/2 is the same as saying the square root of 4. 4 to the 1/2 is 2. Times 5 to the 1/2. I can't simplify that any further, so I leave it as 2 times 5 to the 1/2, and I'm done. When I have a negative exponent, it means put 1 over that base with a positive exponent. So if I put 1 over my base, which is 9, to the positive 1/2, 9 to the positive 1/2 is the same as saying the square root of 9, which is 3. So we wind up with 1/3. A to the m divided by a to the n. So we have like bases here, and this time we are dividing them. So that means we subtract our exponents, and I can't read this. What is that? 3/2 and 1/2? Okay. 3/2 minus 1/2 is 2/2, which gives me 1. So 7 to the first power is 7. And finally, I have a fraction here to a power, so I can send that power to both the numerator and the denominator. Is that 1/2? No, it's 1/3. So it becomes 5 to the 1/3 divided by 27 to the 1/3. I can't simplify 5 to the 1/3, so it stays 5 to the 1/3. But 27 to the 1/3 is the same as saying the cube root of 27, which we know is 3. So that's why that turns into a 3. Okay? But the whole point of this is the properties of exponents that we've been working with still apply, even though we're dealing with fractions. Now that we know that, we can solve some more problems. So we have a couple problems here to simplify and a lot of space to do it. Yeah, could be bad, but it might not be. So simplify. Previously, we had been working with nth roots, and we'd have to deal with these as nth roots. But now that we know that we can convert nth roots into rational exponents, it's going to make life a little bit easier, hopefully. So I'm going to do just that. I'm going to convert the 4th root of x to the 3rd to a rational exponent. What will it be? X to the 3/4 divided by x to the 2/8, but 2/8 reduces to 1/4. So now I'm dividing like bases. What do I do with my exponents? I subtract them. So that gives me x to the 3/4 minus 1/4, which is x to the 2/4, which is 1/2. What is x to the 1/2 in radical form? The square root of x. There's your answer. Usually working with rational exponents is easier than working with nth roots. And that example right there is a perfect example. Because otherwise we'd have to do a fancy one here. We'd have to multiply top and bottom by the 8th root of x squared to the 7th power, top and bottom, and then simplify all that down. It's crazy. It'd take forever. Way faster doing it this way. So how about this one? What could we do? Seven to the 1/2. 7 to the 1/3. Good. All right, so we are multiplying like bases. So what do we do with our exponents? Yeah, we have to add them. How do I add 1/2 plus 1/3? Common denominator. So I have 7 to the, what is my common denominator going to be? 6. So 1/2 turns into 3/6, and 7 to the what sixth here? 2/6. So now I have like bases and I can add my exponents. 7 to the 5/6. And if they ask me to put it back in radical form, I would write what? The 6th root of 7 to the 5th power. And you're done. So switching to exponential form and then working with it is going to be easier most of the time than working with nth roots. Okay, lots of words. When evaluating rational exponents by hand, convert any decimals to fractions. All right. Then you can either apply the numerator first, which means raising the base to a power, or you can apply the denominator first, taking the nth root of the base, and then apply the other. You can do them in either order. That's what that property that we learned last time was, that I put a box around. I said this is like the master sort of the entire thing. Okay? Finally, remember that a negative exponent just means to take the reciprocal of the base, not make the base negative. A negative exponent has nothing to do with the sign of the number. It just means take the reciprocal of it, put it in the denominator, or if it's in the denominator, put it in the numerator. Sure, you can change it to a positive exponent first, or you can change it to a fraction first. Okay, fine, fraction first. 16 to the negative what? 5/2. How did I get 5/2 from 2.5? Because 0.5 is 1/2. So therefore, if I have 2.5, then I have 2 and 1/2. And then I convert it to an improper fraction. 2 times 2 is 4 plus 1 is 5. So you get 5/2. If I take 2 and I divide it into 5. 2 divided into 5. 2 times, and I get 4, right? And I'm left with 1. That's a remainder of 1. How do I write my remainders? Now that I know how to do long division for real this time, not second grade way. I write plus 1 over what I divided by. What's 2 plus 1/2? 2 and 1/2. Which is 2.5. Yeah. All right, so now we have 16 to the negative 5/2. So what do I need to do now? We make the exponent positive. To do that, 1 over 16 to the 5/2 now. If I were to write that as a radical, in radical form, that would be 1 over the what? The square root of 16 to the 5th power. Or, hang on, hold on. Slow your roll. I could write it like that, meaning I would have to raise 16 to the 5th power, which is probably a pretty huge number, and then take the square root. Or I could write it like this, 1 over the square root of 16 to the 5th power. Either one of these is correct, and that's what this is saying up here. When it says either, you can apply the numerator first, raising the base to a power, that would be what we would be doing in this case. Or you can apply the denominator first, taking the nth root first, and then applying the power. So which one would you rather do if you had to do this by hand? Would you rather raise 16 to the 5th power and then try to take the square root? Or would you rather take the square root of 16 and then raise that to the 5th power? I would rather take the square root of 16 because I know what that is. It's 4. And then 4 to the 5th I can find out. I can just go 4 times 4 times 4 times 4 times 4, right? But on this one, I'd have to do 16 times 5. Like if there's an electromagnetic pulse and for whatever reason I had to find out what 16 times to the 5th power was, I had to do it by hand because none of the electrical things that we have work anymore, which is terrible because that's like half my life because I spend, every 20 minutes updating Facebook just to see what happened. No. Right. I don't, by the way. I just made it up. But that's terrible. I don't want to do that. I'd much rather do this. So that's why this little sentence right here is so important. So in this case, I can take the square root of 16 first, and then raise that to the 5th power, and that's exactly what I'm going to do. So I have 1 over 4 to the 5th power. That's 4 times 4 times 4 times 4 times 4. 1025? Are you sure? Okay. 4 to the 5th power wound up being a number that ended in 5.
Oh, 4. 1024.
Okay, that's better. 1 over 1024. That's your answer. The 1 in the numerator? Yeah. If you didn't put the 1 there, then what would you have? It's 1 over 1024. 1,024th. You have to have it there. All right, how about this one? What should we do first? It's good first step. Put what in the numerator? I keep it like what?
Well, if it's a negative number, it has to go underneath. It has to be 1 over.
It's an odd index, so you can put it in the radical form.
I don't want to, though. So let's first address this 1 over situation that we're dealing with here. Do we have to make it 1 over 32 to the 4/5? Should we? Yes, it is a negative number. It's not a negative exponent. A negative number has nothing to do with a negative exponent. This does not in any way say 1 over 32 to the 4/5 power. This is a negative 32. We are raising negative 32 to the 4/5 power. That is not a negative exponent. Okay, this is the classic mistake that people make. Just because it's a negative number doesn't mean that we have to move it to the denominator. It's just a negative number. Now we can either take the 5th root of negative 32 first and then raise whatever that is to the 4th power. Or we can raise negative 32 to the 4th power first and then take the 5th root of it. Because we don't have a calculator to work with here. No, that's the whole point of this. Yes, I know, you can plug negative 32 into your calculator and raise it to the 4/5 power and get the answer. But right now we're trying to make our minds grow a little bit. Is it quicker that way? You want to race? What's the 5th root of negative 32? In other words, what number times itself 5 times gives me negative 32? Negative 2. What's negative 2 to the 4th power? 4 times 2 times 2 times 2 times 2 is 16. But it's negative 2 times negative 2 times negative 2 times negative 2. It's still 16. So why? How did we get 16? Well, we said I could convert this to the 5th root of negative 32 to the 4th power. Or I could write it as the 5th root of negative 32 all to the 4th power. This is what I did. I took the 5th root first. The 5th root of negative 32 is negative 2. The number times itself 5 times that gives me negative 32 is negative 2. So now I have negative 2 to the 4th power. That's negative 2 times itself 4 times, which is 16. So I'm using this sentence right here that allows me to do this either way. Sometimes the denominator is going to be better to do first. Sometimes the numerator is going to be better first. So how about 16 to the 3/4? I'm already done if you're trying to type it into your calculator.
So it's 12.
The fourth root of 16 is 2.
The 4th root of 16 is 2. To the 3rd is...
Can you write that out?
Yes. I have the choice of either the 4th root of 16 to the 3rd, which means I have to find 16 to the 3rd first and then take the 4th root of that. Or I can go the 4th root of 16 first and then raise that to the 3rd power. The 4th root of 16 I know. 2 times itself 4 times gives me 16. So the 4th root of 16 is 2. And then 2 to the 3rd is 8. So therefore 8's my answer. Now in all these examples it was easier to take the root first than raise to the power first. And usually that's the case. But sometimes that's not quite the case. So you can go either order, just so you know. All right. Using the properties of exponents, write each expression in simplest form. This is like the main thing of the section right here. So here we go. I'm using all of my properties of exponents. So when I look at this problem, I see some stuff raised to a power. What should I probably do first? Send the power in. So what will I write?
Wait, can you write the square root before we start?
Can I take the square root of the square root? Can I take the square root of x? Well, the square root of x can be written as x to the 1/2, right? So then I'd have the square root of x to the 1/2, right? But this thing can be written as this to the 1/2 power, so that becomes x to the 1/2 to the 1/2. When I have powers to powers, what do? Multiply the exponents. So when I multiply those together, I get x to the 1/4.
So you just add the index.
I did not. No, you don't just. You can't just ever. You would want to rewrite it like this, because if I had like the 3rd root of x squared, and then I had the 5th root here, if you added 3 plus 5, that'd be 8. But I'm not necessarily going to get that because I have to make a common denominator and all that other stuff. So don't just, okay? If you're presented with a problem like this, I would switch it to this and then do that. That has nothing to do with what we're doing here, though. Well, okay, we were starting to send in our exponents, so let's do that. What do I write? -8 to the 2/3, x to the 2/3. And now what is this right here? But it's xy to the 1/2, right? That's to the 2/3. So you're going to want to write all your exponents out, not radicals. Use exponents only when you're doing these problems. Okay, now, -8 to the 2/3. I have a choice. I can square first and then take the cube root, or I can cube root first and then square. Cube root first. The cube root of -8 is -2, and then I square and I get +4. X to the 2/3 becomes x to the 2/3. xy to the 1/2 to the 2/3, what do we need to do there? This is a power to a power, so we multiply the exponents. So this is xy to the 2/6, which is 1/3. And now the question is, are we done? No, sir.
No, because we have
We have more like bases that we can combine. This is 2 bases to a power here. So we continue. 4x to the 2/3 times what? X to the 1/3, y to the 1/3. Now what?
So then we have 4x to the first, so it's just x.
Good.
Then y to the 1/3.
Yes, like bases, add the exponents. 2/3 plus 1/3 is 3/3, which is 1. So we get x to the first, or just x, y to the 1/3. And if you were supposed to write that back in radical form, then you would write 4x times the cube root of y. Okay? So it just depends on how they were asking you for your answer. This is probably good enough, but they might ask you to go back to that. Next one. Here we go. Distribute the exponent. We're raising powers to powers, so we can send that exponent in. We get...
Hold on first.
Oh.
1. Put 1 over it all.
Oh, why? Yeah, we have a negative 3/4 out. So we can go 1 over right now and take care of that negative right now. That's what we're doing. Why?
Because you put it over 1.
No, I didn't. I took care of the negative exponent here.
So, hold on. So you gotta move that back up, right?
The negative exponent put this entire thing under the 1.
So now you have to put that under 1, and then it's under another 1. So it's like 16y to the 8.
How can I send in this 3/4?
Send it in.
All right, so now I have 1 over
16 4.
y to the
-8.
negative 24/4, which is negative 6. Now I can take care of that negative exponent. With a negative exponent in the denominator, where does it go? It's already in the denominator. It moves to the numerator.
So it'd be y to the 6 divided by 16 3/4.
Wait, you can argue, because you know for that 3/4, that the root of 3/4 is 2, so 2 to the 3rd is 8. So I'm thinking
We have the 4th root of 16, which is 2. 2 to the 3rd is 8. So we can turn this into y to the 6th divided by 8, and we're done. There's probably 18 different ways you can go about doing this problem. You can distribute the negative 3/4 exponent in first. If you did that, then you'd have 16 to the negative 3/4, y to the positive 6. And then the 16 to the negative 3/4 would go to the denominator, and we'd be here at that point. And then you can go here. Or you can do what we did first here, and then put this y to the negative 8th in the denominator here. And then send the 3/4 in. And then leave it, change it, flip it. There's lots of different ways you can go on that problem. There's lots of different ways you can go on all these problems. Just be methodical about the way that you do it, and you will arrive at the same answer. One way may be shorter than the other. Let's do this last one. Pick what? Pick something. Somebody suggest something. Distribute the exponent. Okay, what I'm going to do first before we distribute the exponent, that is what we're going to do, is I'm going to rewrite this radical since we're dealing with radicals and rational exponents. I want just rational exponents. So 9x to the 4th, y to the 1/2. This is all to the 3/2 power. Okay, now I'm going to follow the suggestion of distributing the exponent in, because this is all stuff being multiplied together inside. So what do I get? 9 to the 3/2 powers to powers. So I multiply 12 halves, which is 6, y to the 3/4. Powers to powers, you multiply exponents. All right, 9 to the 3 halves.
Okay, so 3
The square root of 9 is 3. To the third is 27. X to the 6th, y to the 3/4 power. If you had to write that back in radical form, by the way, this is the answer right here. But if you had to write that back in radical form, then you would write what?
27, 6.
X to the 6th.
Oh, wait. Then why is this math?
X to the 6th is x to the 6th. Times the 4th root of y cubed. Okay? So you can go from one to the other quickly. It just depends on the form that they're asking you for. This is the appropriate answer here. Look in the back. If it goes to this, then change your answer to this.